Solar panel metallization, discoloration and corrosion. The discoloration and corrosion of the cell metallization and the interconnections is getting visible as a light yellow to dark brown to black discoloration of the electrical parts. Depending on the material combinations, corrosion is furthermore noticeable by the presence of galvanic products that may appear powdery, white, light gray, and have a yellow, blue, or green tinge. The defect occurs typically at the solder bonds, on the cell gridlines and fingers or the cell and string interconnect ribbons. It is very often observed together with other failures like delamination and discoloration of the encapsulant and sometimes with burn marks. Under certain circumstances, corrosion is more visible near cell edges. Dark areas at the cell borders of the electroluminescence images can here highlight the diffusion of moisture through the rear side of the module and the gaps between the cells and the subsequent front side cell corrosion starting from the edges. The oxidation of the metallization is caused by the presence of moisture and acidity in the encapsulant, as for example acetic acid, a degradation product of the mostly used encapsulant ethylene vinyl acetate or remaining crosslinker, peroxides. Acetic acid has a corrosive effect on the cell metallization and the cell interconnect. The ingress of moisture caused by an ongoing delamination process leads together with the oxygen to a further acceleration of the corrosion. Corrosion can be caused by a poor manufacturing process, like residual crosslinker due to a too short lamination process, imperfections in cell soldering, or the choice of poor materials, low corrosion resistance of tin-based coating of copper ribbons, high water permeability of backsheet and encapsulant materials. Environmental factors can accelerate the corrosion, like ammonia, salt, humidity, temperature. For these reasons, corrosion is more frequent and severe under hot and humid climates or in agriculture or maritime environments. Discoloration can be also related to non-corrosive processes like a discoloration due to light-sensitive solder flux residues on the ribbon. The metallization and interconnect corrosion leads to an increased series resistance and therefore losses in module performance. The power loss is less pronounced for modules with metallization discoloration without corrosion. The defect does not automatically pose a safety issue. Locally increased series resistance leads to current mismatch. If the mismatch is getting significant, it can trigger the bypass diode and cause further power loss of the solar module. Modules with a direct safety risk should be replaced. Regular inspections should be done to monitor the status of the not replaced modules.